Off the coast of Okinawa, in the East China Sea, morning light appears over Task Force 58 of the United States Fifth Fleet. On radar picket ships stationed 16 miles from the main group of ships, sailors watch the skyline, knowing what is coming. In the command center of the USS Laffey, radar men follow incoming targets, not just a few, but hundreds. The ship's 5-inch gun teams load shells with strange VT labels, each one holding tiny radio senders that would completely change sea combat. The mission is a desperate one: to survive the first of 10 huge, planned kamikaze attacks. At 6 a.m., the sky becomes crowded with airplanes. Through the morning fog, a sound arrives that will mark the Battle of Okinawa, the hum of hundreds of Japanese plane engines getting closer in groups. The pilots are locked in their cockpits with no plan to come back. Before we dive in, tell us in the comments where you're tuning in from. And if stories of heroes appearing in the darkest hour thrill you, then hit subscribe, because we're just getting started. Leading the charge are pilots from the Imperial Japanese Navy's Special Attack Teams. Their Zero fighters and Judy dive bombers carrying 550-pound bombs are followed by waves of older planes put into service for one-way missions. Among them, specially prepared Oka pilots are sealed inside rocket-powered flying bombs carried by Betty bombers. What occurs next will show the game-changing effect of American proximity fuse technology and explain why Japanese kamikaze methods, at first so destructive, would in the end fail against the most advanced anti-plane defense system ever used. The American VT, proximity fuse, had reached the Pacific War Zone after 2 years of battle trials that started with a single famous shot. It was created through an urgent project begun in 1940 by a special team at the Johns Hopkins Applied Physics Laboratory, led by Dr. Merrill Tuve. The proximity fuse was one of the 3 most important secret projects of World War II, along with radar and the atomic bomb. The fuse worked on a brilliantly easy idea: a small radio sender and receiver that would send out steady radio waves and check the waves that bounced back. When a change in the radio waves showed it was near a target, the fuse would set off the shell on its own. Gunners no longer had to guess exact distances and set mechanical timers. The shell would know when to blow up. The technical problems had been amazing. The fuse's parts, including tiny glass vacuum tubes made by Sylvania, had to survive the force of being fired from a 5-inch gun, a force 20,000 times gravity. The shell would travel at 2,600 feet per second while spinning at 25,000 times per minute. Every part had to work just right after this rough launch, and then perform dependably in weather from hot to freezing. By April 1945, American factories had made over 15 million proximity fuses for the Navy in the Pacific. The work was spread among many companies. Crosley Corporation alone made over 5.2 million fuses, 24% of the total. Many other firms using 110 factories were involved in making them. This huge factory effort made sure that American forces at Okinawa had the best anti-plane ammunition ever made. The United States Navy had raised its use of proximity fuses from 25% of its anti-plane supply in 1943 to 75% by 1945. This showed they understood that fighting kamikaze attacks in the Pacific needed new defensive powers. Every destroyer, cruiser, and battleship had thousands of VT-fused shells for their main protection against suicide attacks. In sharp opposition was the Japanese kamikaze program, which came from a feeling of hopelessness. After terrible losses in the Marianas and the Battle of the Philippine Sea, Japan had lost most of its skilled pilots and aircraft carriers. Vice Admiral Takejiro Onishi, head of the 1st Air Fleet, had suggested forming special attack units in October 1944. He claimed that normal methods could no longer work against the immense American shooting power. The kamikaze was Japan's effort to turn its few remaining rookie pilots into precision-guided weapons. The numbers seemed promising. While normal attacks had a success rate of only 2% against well-defended American ships, early kamikaze attacks in the Philippines had a success rate over 34%. A single pilot in a Zero fighter with a 550-pound bomb could possibly sink a destroyer, giving up 1 life and 1 old plane for hundreds of American losses and millions of dollars in ship damage. The Kamikaze pilots had shortened training that focused on mental readiness over flying ability. Many had flown for less than 100 hours, unlike the 500-plus hours of the pilots at Pearl Harbor. They learned basic direction finding, how to spot ships, and most importantly, the final diving method to avoid anti-plane fire. The pilots wrote goodbye letters, took part in special sack toasts, and were given samurai swords or headbands before their missions. But no amount of mental readiness could beat the new wave of technology they were about to face. The Oka suicide weapon was the final form of the kamikaze idea. Called Baka, meaning fool, by American sailors, this piloted bomb had a 2,600-pound warhead and was pushed by 3 solid-fuel rocket engines. With a top speed of 575 mph in its final dive, it was meant to be unstoppable once let go. But its key weakness was its short range, just 10 miles, which meant weak Betty bombers had to fly them right into the face of American defenses. The difference in defense ideas was total. American ships at Okinawa were set up in circles of defense, with radar picket destroyers placed to give early notice and take the main hit of the first attacks. Each destroyer had 12 to 16 5-inch guns that could fire VT-fused shells, making overlapping areas of fire. The proximity fuse changed these weapons from simple defense systems into precise tools. A 5-inch VT shell had a deadly explosion area of 70 feet, compared to just 20 feet for time-fused shells. More importantly, the fuse got rid of the hard math needed for normal anti-plane shooting, letting gunners attack targets as soon as they were seen. The morning of April 6, 1945, would be the final test for these systems. The first major attack involved 391 Navy planes and 133 Army planes, with a total of 297 suicide planes in one big, planned assault. Commander Frederick Julian Beckton of the USS Laffey later said the coming kamikaze groups looked like a swarm of bees flying to the only flower in a desert. The first group hit at 6 a.m., with radar men tracking over 50 planes coming from the north. The picket destroyers started shooting at their farthest range, 12,000 yards, with VT-fused shells. The proximity fuses were incredibly successful against the incoming groups. Each shell that got close enough to a plane blew up on its own, filling the air with metal pieces. Unlike time-fused shells that needed exact range guessing, the VT fuses made near misses into direct hits. In just a few minutes, dozens of Japanese planes were crashing into the ocean. Their one-way missions were over miles from their goals, but the kamikazes continued to come. At 7:44 a.m., the USS Laffey was heavily attacked by 22 planes in 80 minutes. The ship's gunners shot 345 rounds of 5-inch VT ammunition, taking down 9 attackers completely. The proximity fuses let the Laffey's guns attack many targets at once, quickly changing from one plane to another without the usual delays for setting fuses. When kamikaze pilots tried their normal method of flying very low to the water to stay off radar, the VT fuses worked just as well, blowing up when the shells got close to the sea and making walls of metal that tore up low-flying planes. Even with this amazing defense, the Laffey was hit by 6 kamikazes and 4 bombs, but it stayed afloat. This was a credit to both American damage control and the fact that proximity fuses stopped many more attackers from reaching the ship. The success of the VT fuse was not by chance. The technology had been secretly tried in battle since January 5, 1943, when the USS Helena shot the first proximity-fused shells near Guadalcanal. A lieutenant in charge of a 5-inch gun battery shot down a Japanese dive bomber with the second of 3 tries. The shells had exploded without hitting the plane directly. They had just gotten near enough to set off the fuse and rip the plane apart with shrapnel. This one success proved 3 years of hard work that had solved seemingly impossible technical problems. The fuse had about 130 electronic parts, shrunk to fit in a space smaller than a milk bottle, all made with extreme precision. After the Okinawa campaign, a review of the battle showed the clear advantage in numbers of proximity-fused ammunition. Time-fused shells took an average of 1,162 rounds to take down each kamikaze. VT-fused shells lowered this to 310 rounds per kill, a nearly 4-fold increase in success. In the best situations, the results were even better. The destroyer escort USS Abercrombie took down a Kamikaze with only 2 VT rounds in May 1945. The destroyer USS Morrison, fighting off a huge Kamikaze attack on May 4th, shot down 8 attackers in minutes using proximity-fused ammunition before being overcome by the sheer quantity of planes. The mental effect of the proximity fuse on Japanese pilots was deep. Kamikaze pilots who survived by turning back reported the scary experience of flying toward American fleets through what felt like solid walls of exploding shells. The black puffs of VT explosions seemed to happen with strange accuracy, as if the American gunners knew exactly where each plane would be. Japanese battle plans had been based on the idea that fast, low-flying approaches would reduce the time they were exposed to anti-plane fire. The proximity fuse proved these ideas wrong. Shells that would have missed by 50 feet with old fuses now exploded lethally close, making the final approach a dangerous path of perfectly timed explosions. Vice Admiral Matome Ugaki, who was in charge of kamikaze operations, wrote in his diary about the growing power of American anti-plane defenses. By late April 1945, Japanese naval intelligence thought that less than 1 in 4 kamikaze planes were reaching their targets, down from 1 in 3 during the Philippines campaign. The change was mostly blamed on what Japanese reports called new-type anti-aircraft shells that seemed to burst with impossible correctness. Ugaki wrote, "The enemy's defensive firepower has grown greatly. Our special attack planes are being shot down at distances we used to think were safe. Individual American sailors using the 5-inch guns with VT ammunition became heroes in their fleets. On the destroyer USS Hugh W. Hadley, during a May 11th attack, gun teams were credited with 17 confirmed kamikaze kills using proximity-fused ammunition. The gunners learned a method of leading kamikaze planes with non-stop fire, making a wall of explosions that attacking planes had to fly through. Their gun teams could fire 15 rounds a minute, each shell having its own electronic brain looking for targets. In one 52-minute stretch, the Hadley's guns took out several kamikazes one after another, with the proximity fuses making sure that even shells passing above or below the fast-moving planes would explode with effect. The story of the USS Aaron Ward during the May 3rd attack shows the proximity fuse's role as an advantage. When 40 kamikaze planes attacked the destroyer, its 5-inch guns fired for 52 minutes straight. The VT-fused shells destroyed 6 attackers completely and damaged 5 others so badly they fell into the sea. Commander William Sanders later said that without proximity fuses, his ship would have been defeated in the first 10 minutes. The power to attack targets without exact range finding let the Aaron Ward's guns switch quickly between many threats, which was impossible with time-fused ammunition. These stories were repeated all over the fleet. During the 10 major Kikusui operations from April 6th to June 22nd, 1945, Japanese forces sent about 1,100 planes in planned kamikaze attacks. American naval forces, mostly using VT-fused 5-inch shells, destroyed hundreds of these attackers before they could reach their goals. Numbers from a research group showed that ships with proximity-fused ammunition were 3 times more likely to survive heavy kamikaze attacks than those using mostly old-style ammunition. The proximity fuse had changed what should have been a devastating new tactic into a costly but controllable danger. The gap in technological progress became clear as the fight went on. American forces kept improving their proximity fuse tactics, finding that VT shells were especially good when fired in ways that created overlapping zones of metal pieces. Ships started to coordinate their fire to make these VT boxes that kamikaze planes had to fly through. The Japanese, on the other hand, could only try different tactics like dawn attacks, coming from multiple directions and mixing normal and suicide planes, none of which could beat the basic advantage of shells that knew when to blow up. The production numbers told the story of factory-based war at its peak. By June 1945, American factories were making 70,000 proximity fuses a day. The whole war effort would see over 22 million proximity fuses made, at a cost of over $1 billion at the time, which is about $15 billion today. The Crosley Corporation alone had 10,000 workers on 3 shifts, 7 days a week. The cost of each fuse had dropped from $732 in 1942 to just $18 by 1945 because of mass production. This huge spending was proven to be worth it when Navy studies showed that proximity fuses saved dozens of ships during the Okinawa battle alone. Japan's factory power, ruined by air raids and a lack of materials, could not make anything like it. While Japanese scientists knew about the proximity fuse idea, German reports, Allied special ammunition had reached Japan by submarine. They did not have the factory set up to create and mass-produce such advanced devices. The vacuum tube technology by itself needed a level of precise manufacturing that Japan's war-torn industry could not deliver. Japanese radar development, which was key to understanding proximity fuse ideas, stayed basic compared to American systems. The Type 22 radar, Japan's best naval radar, used wavelengths that made making it smaller impossible, even if they had the factories. The success of the proximity fuse changed Japanese battle plans in the last parts of the campaign. By May 1945, Kamikaze pilots were told to fly toward American fleets at the highest possible altitude before diving straight down on targets, hoping to spend less time in the range of VT-fused anti-plane fire. This change in tactics, while it cut down on losses during the approach, made accurate aiming almost impossible. Ships could move out of the dive path, and the high-altitude approach gave radar operators more time to track the incoming planes. The attempted fix did more harm than good. Admiral Richmond Kelly Turner, the head of the landing forces at Okinawa, said proximity fuses made the invasion possible. In a letter to the Chief of Naval Operations, Turner wrote, "Without the VT fuse, our losses from suicide attacks would have been too much to handle." The Japanese Kamikaze was a powerful weapon that could have changed the result of the Pacific War, if not for our better technology in anti-aircraft defense. His view was shared by Admiral Mark Mitcher, whose main ship, the USS Bunker Hill, survived a terrible kamikaze hit on May 11th, partly because proximity-fused fire destroyed 3 other attackers that would have finished off the damaged carrier. Admiral Arleigh Burke, Mitcher's chief of staff, later remembered the power of proximity fuses in a 1978 interview. "When I went as chief of staff to Admiral Mitcher, all the 5-inch ammunition was fitted with VT fuses, and as you well know, those fuses knocked down enemy planes by the dozens. If it had not been for those fuses, our ship losses and casualties would have been enormously larger. The proximity fuse's effect went beyond just numbers. The technology basically changed the balance of spirits that made kamikaze tactics work. Japanese military thinking assumed that the certainty of death for their pilots would be offset by the near certainty of hitting enemy ships. When success rates fell below 20% because of proximity-fused defenses, the trade-off could not be continued, even by the harsh math of suicide warfare. Young Japanese pilots, many of them college students pulled into the special attack units, started to realize that their deaths would probably accomplish nothing. Letters found after the war showed a growing understanding among kamikaze pilots that American defenses had improved beyond what their leaders had told them. The first official kamikaze unit leader had great success in October 1944 when proximity fuses were only 25% of the anti-plane ammunition. By Okinawa, his followers faced a completely different situation. A commander leading a corps with Oka flying bombs lost his whole group on March 21, 1945, without a single Oka getting to its launch point. American fighters, directed by radar, shot down all 18 Betty bombers. But even if they had gotten through, the wall of VT-fused anti-plane fire would have been impossible to break. The advanced technology of the proximity fuse was more than just better manufacturing. The device showed major progress in electronics, material science, and putting systems together that Japan could not equal. The tiny vacuum tubes used special glass that could take a huge shock. The battery system, started by the force of firing, used a liquid that stayed good for months, then worked instantly when needed. The radio signal was carefully set to reduce interference while getting the best detection range. Each part was the result of years of dedicated research with endless funding. Meanwhile, Japanese anti-plane defenses were still simple. Their best heavy anti-aircraft guns still used mechanical time fuses that had to be set by hand for each shot. Japanese Navy ships at Okinawa, including the giant battleship Yamato on its last mission, had anti-plane ammunition that was technologically the same as what Americans had used at Pearl Harbor. When the Yamato faced over 300 American planes on April 7, 1945, her 162 anti-plane guns fired thousands of shots but took down fewer than 10 attackers. The Americans lost only 10 planes while sinking the world's biggest battleship, a clear sign of the technology gap. The proximity fuse also allowed for new battle tactics that were not possible with old ammunition. American destroyers created the VT umbrella tactic, shooting proximity-fused shells in set patterns above friendly ships being attacked. The shells would blow up at certain distances, making a protective dome of metal pieces that kamikaze planes had to fly through. This method was very good against the Oka flying bombs, whose high speed made them almost impossible to track with normal fire control. But they were open to the wall of metal pieces made by VT patterns. During the entire Okinawa fight, from April 1st to June 22, 1945, the United States Navy used about 150,000 proximity-fused 5-inch shells. The success was clear. While VT-fused ammunition was 45% of the heavy anti-plane ammunition shot, it was responsible for most of the confirmed kamikaze kills at longer distances. Time-fused shells, making up 55% of the ammunition used, were mainly good at close range where accuracy was less important. The numbers showed that proximity fuses were about 3 to 4 times better than old ammunition against kamikaze attacks. The difference in human cost was just as striking. Ships that ran out of their VT ammunition and had to use time-fused shells had much higher loss rates in later attacks. The destroyer USS Drexler, attacked after using up her proximity-fused ammunition on May 28th, was sunk in under a minute by 2 kamikazes that probably would have been stopped by VT fire. Her 158 dead were more losses than many destroyers had in entire campaigns. Admiral Raymond Spruance, head of the Fifth Fleet, felt the kamikaze danger himself when his main ship was hit in March, making him move to another ship that was also hit in May. He later wrote, "The suicide plane is a very effective weapon, which we must not underestimate." Yet, Spruance also knew that without proximity fuses, the kamikaze would have been much more destructive. The VT fuse has saved countless ships and lives. It is the difference between bearable and unbearable losses. The strategic meaning was obvious to military leaders getting ready for the planned invasion of Japan. Intelligence reports said that Japan had saved about 10,000 planes for kamikaze attacks on the invasion fleet. But American war planners, sure of the proximity fuse's power, figured that their defense needs could be met. Production of VT fuses was set to reach 100,000 units a day by September 1945. New, better fuses were being mass-produced. The invasion fleet would have carried over 1 million proximity-fused shells, making an anti-plane defense never before seen in military history. The atomic bombings of Hiroshima and Nagasaki in August 1945 stopped the war before this final test could happen. But the proximity fuse's role in Japan's decision to give up should not be overlooked. Japanese military reports found after the war admitted that a successful defense against an invasion fleet protected by what they called electronic shells was impossible. The chief of the Naval General Staff testified after the war that the Japanese Navy had figured that kamikaze attacks on the homeland would have less than a 10% success rate against proximity fuse defenses, a rate that would make the tactic militarily useless. After the war, studies showed the full size of the proximity fuse accomplishment. The program had involved 112 companies besides the main ones, making an industrial network dedicated to creating the most advanced military electronics of the time. British scientists, who first had the idea for the proximity fuse in 1940 but didn't have the means to develop it, admitted that American factory power had done what they thought was impossible. The British had decided that making vacuum tubes survive a gunshot was an unbeatable problem. American engineers proved them wrong. The success of the proximity fuse against kamikaze attacks shaped military technology for decades. The idea of smart weapons that could think for themselves became a key part of American military thinking. Modern anti-plane missiles use proximity fusing that came from the VT fuse, while today's ship protection systems work on ideas first used in the defense against kamikazes. The technological advantage that beat human. Guidance with electronic smarts created a new model that still shapes military plans. Japanese veterans interviewed. After the war still showed surprise at American proximity fuse technology. A commander who helped start the Kamikaze program admitted, "We knew the Americans had better technology, but the proximity fuse was beyond what we could imagine. Our pilots said shells exploded exactly where they flew, as if guided by unseen hands. It destroyed not just our planes, but the whole idea of the special attack that spiritual strength could beat material advantage." A captain, who was an early supporter of kamikaze tactics, survived the war and later thought about the proximity fuse's effect. "We believed that being willing to die would ensure success. The American electronic fuse proved that technology could beat even the most dedicated human sacrifice. It was not just a weapon, but a message about how modern war is fought. The difference between the proximity fuse and kamikaze attacks showed fundamentally different views about the value of human life and the part technology plays in war. The American focus on saving lives through better technology was up against the Japanese willingness to use life as a weapon. The proximity fuse, by making kamikaze attacks survivable for American forces, made the cruel thinking that sent young Japanese men to their planned deaths useless. In this way, the electronic fuse was not just a sign of better technology, but a moral statement about how wars should be fought. The legacy of the proximity fuse in beating kamikaze attacks goes beyond military history. The urgent development project that made the VT fuse became the pattern for later American technical successes, from the space program to modern computers. The teamwork between universities, private companies, and the military that made 22 million advanced electronic devices during the war showed American organizational skills that would define the post-war period. The lab where the proximity fuse was perfected continued as a hub of military technology, creating everything from guided missiles to satellite navigation. Dr. Merle Tuve, who led the proximity fuse project, later looked back on the work. "We saved lives by making weapons more effective. Every kamikaze shot down by a proximity fuse meant American sailors who went home to their families. That was worth any amount of work and money." His team's success proved the American method of using scientific knowledge for military problems, a way of thinking that would guide defense plans through the Cold War. For the Japanese, the failure of kamikaze tactics against proximity-fused defenses was the end of their beliefs about spiritual strength beating material weakness. The young pilots who died in pointless attacks against walls of VT-fused explosions became symbols not of noble sacrifice, but of a military leadership that had not seen the technological truth. Modern Japan's focus on technological growth and new ideas can be partly linked to the hard lessons of 1945, when electronic fuses beat human pilots with mechanical correctness. The mathematical rightness of the proximity fuse's success, 10 rounds per kill versus 1,162 for time-fused shells, led to saved ships, protected lives, and in the end, a strategic win. Each VT fuse that worked correctly meant an American sailor returned home, a ship survived to fight again, and proof that technology could give a clear advantage in modern war. The confirmed takedown of hundreds of kamikaze planes by proximity fuses before they reached their targets meant thousands of American injuries were avoided. Dozens of ships were saved, and the billion-dollar spending on electronic warfare was justified. The story of technology beating fatalism had its high point in the waters of Okinawa, where radar-guided fighters, proximity-fused anti-plane shells, and advanced damage control systems won against deliberate suicide attacks. The kamikaze pilots, brave young men given up for a lost cause, flew into an electronic death trap their leaders never saw coming. Their deaths, while causing tactical damage that shocked American sailors, did not reach the strategic aim of making the cost of invasion too high. The proximity fuse had turned their sacrifice from a devastating weapon into a manageable danger. The Secretary of the Navy, James Forrestal, summed up the proximity fuse's contribution. "The proximity fuse has helped blaze the trail to Japan. Without the protection this clever device has given the surface ships of the fleet, our westward push could not have been so quick, and the cost in men and ships would have been immeasurably greater. This view, shared by military leaders all over the Pacific, acknowledged that electronic smarts had beaten human sacrifice. The final count was serious but clear. During the whole Okinawa campaign, Japanese kamikaze attacks sank 36 American ships and damaged 368 others. As awful as these losses were, they meant that the great majority of ships attacked survived, a rate that would have been impossible without proximity fuses. The 4,907 American sailors killed by kamikazes at Okinawa, while being the Navy's worst battle, were a small part of the losses that standard analysis expected without VT technology. Japanese losses were total. About 1,900 planes and pilots were used up in planned kamikaze attacks, plus hundreds more in last-minute suicide tries, getting tactical results that were far from what was needed strategically. The proximity fuse's win over kamikaze attacks showed that in modern war, technological advantage could beat advantages in numbers, willpower, or even a willingness to die. The American sailors at the 5-inch guns with VT ammunition had a clear advantage over Japanese pilots locked in cockpits for one-way trips. The tiny radio sender in each shell's nose stood for factory power, scientific knowledge, and organizational skill that no amount of martial spirit could equal. When the electronic fuse met the human pilot in the skies over Okinawa, the result was decided ahead of time by factories in Cincinnati, labs in Maryland, and the basic American belief that technology could save lives while winning a victory. The mathematical truth was unavoidable. A proximity fuse weighing less than 5 pounds, with 130 electronic parts made for $18 by 1945 and working for less than 30 seconds, could destroy a kamikaze plane with its pilot, who represented years of training, tons of metal, and most sadly, a human life that could never be brought back. When this was repeated in thousands of fights across the Pacific, this equation resulted in an American victory through technological advantage that helped decide the war's end. The success of the proximity fuse against kamikaze attacks proved the whole American way of war in the 20th century, putting money into technology, having faith in factory production, and believing that better equipment could beat fierce willpower proved right in the hardest test one could imagine. For Japan, the failure of the kamikaze against proximity fuse defenses was not just a military loss, but a rejection of core beliefs about spirit winning over matter. The electronic fuse had beaten the divine wind, proving that in the fire of modern war, advanced technology would win over human sacrifice. The Pacific War showed that in modern sea combat, the power to destroy planes at a distance decided who survived. Nations that could design, make, and use better defensive technology had clear advantages over those that depended on human courage alone. The comparison of the proximity fuse versus the kamikaze shows this idea at its most basic level, American electronic advancement beating Japanese human sacrifice. The VT fuse's success at Okinawa made technological advantage the key factor in military power. The difference between American and Japanese ways of anti-plane defense ultimately tells a bigger story about factory-based warfare in the 20th century. Nations that could gather scientific knowledge, manufacturing skill, and organizational talent to make better military technology had unbeatable advantages. The proximity fuse was the high point of American strengths, new engineering, mass production, and a systematic way of solving problems applied to military needs. Its victory over the kamikaze showed for sure that in modern war, the win belongs to those who can think, build, and use better technology. The mathematical correctness of the proximity fuse's power, 3 to 4 times better than old ammunition, cutting the needed rounds per kill by 73%, and saving countless ships, led to a strategic win that protected American lives while beating a determined foe. This difference, repeated across the huge Pacific war zone, helped ensure an American victory and made technological advantage the basis of post-war military thought. The electronic fuse had not just beaten the kamikaze, it had proven the whole American way of war through better technology, showing clearly that in matters of life and death, the quality of equipment could overcome the quantity of sacrifice.